Today, I will be showing you how to solve the ALEKS problem, identify orbitals in each bond. So what ALEKS is going to do in this problem is it's going to share a compound, and then what it wants you to do is identify the orbitals for each bond as such. So in this case, the first one is going to be from carbon to hydrogen, and then so on throughout the question. The rules that I use to solve this question is single, double, and triple bonds count as one electron group, which I shared in previous videos. Lone pairs only count as one electron group. And then hydrogen orbitals will always be 1s in this question. And then make sure that you're satisfying the octet rule. Again, this is a document you've seen from previous videos, but feel free to copy as needed. But what you want to focus on here is my total domain section, which pretty much equates to the total of electron groups, and then the hybridization, which is going to correlate with the orbitals that's needed. So if you have an electron group of, say, 2, it'll be in domain 2, and then the hybridization or orbital, we'll say, is only going to be sp. Exception to this rule is, of course, for hydrogen, which can only form one bond, really. And for that, I've already put in my rules that we're going to write 1s for this one. All right, so here's the compound, which is CH3NH2, and I kind of got the graphic depiction of it as well. So first, we're going to start by solving or by counting the electron groups around the compound. So we'll start with carbon. Carbon has 1, and I'll number them, 2, 3 to that nitrogen right there, and then 4 to this hydrogen here. And so that has 4 electron groups. So we're going to go back to our sheet, and we see that for really domain 4, for electron groups, we use the hybridization or the orbitals sp3. So in ALEKS right here, we can just write, go pin, there we go. We can go right S, P, and ALEKS is kind of real picky. So make sure that you have your 3 sp and then your 3 towards the top. And then for hydrogen, I've already written the rule on the bottom because it really can only form one bond, one electron group. So for that one, we're only going to write 1s. Next up, we're going to look for the bond between Charlie or for carbon and nitrogen. And I like to use a simple trick on this one because I've already got the hybridization of it before up here in part 1. I can pretty much copy it again because I know that it has these 4 electron groups. So I will write sp3. And then for this nitrogen right here, I'm going to count the electron groups around it using the rules that I put in place. So it's going to be 1 lone pair right here, which is 2. Then we got a bond to hydrogen, which is 3. And then one more bond to hydrogen, which is 4. And as mentioned before in the previous data sheet, we know that that matches up with the orbital or hybridization sp3. And then the last one is going to want to know the bond between nitrogen and hydrogen. So again, your nitrogen, you can just copy it from up here before. We know that that bond for that one is going to be, or that orbital is going to be sp3. And then we already know the orbital for hydrogen from the rule right here, which is in this one is just going to be 1s. And that is pretty much how you solve this problem. If this helped you, or if this helped you or a classmate, feel free to like, share, and subscribe to my channel. Thank you.